So this is on page 13 of your unit handout. It may very well say in your note package, solving radical equations part 1. I don't know if it does or not, but there is no part 2. Okay? I used to have a part 2, but because of the change in the timetable this semester, I removed part 2, which was just kind of elective material. It wasn't necessary. So we're going to be solving radical equations, and we're going to be solving and checking for what are called extraneous roots. Now, this is the first time you've heard this expression, extraneous root. A root is a solution. What an extraneous solution is, I hate the terminology. An extraneous solution is not a solution. What it is a number that you get for a solution when you do all of the math by the rules, but it still turns out the answer you get is incorrect. Okay? I'll give you a very basic example of a radical equation before we get started officially with the lesson. If I gave you the following, negative 10 equals the square root of x minus 5. Would you agree that's an equation? Would you agree there's an unknown in it, x? Okay, so how can we go about solving for x? Well, there's some things in equations we don't like. We don't like fractions. We don't like decimals. And we don't like square roots. So the basic idea here behind what we do today is that you can eliminate square roots under some circumstances. I can square both sides of that equation. And I am allowed to do that. If I say to you that 2 plus 3 is equal to 5, and I square both sides, is this 25? Well, yes, it's still 25. You could FOIL it out if you want to, or you could just say it's 5 plus 5. When I square both sides of an equation, I'm still keeping the truthiness of the equation. It's still a valid statement. So what do I get here? When I square negative 10, I get 100. And when I square the square root of x minus 5, I get x minus 5. Correct? I have not done anything wrong. I haven't. And now I solve by adding 5 to both sides, and I get x equals 105. X equals 105. Let me write down the original equation. $105 is not a solution to that equation. Because if I put 105 in for x, I'm going to have the square root of 105 minus 5, which is the square root of 100, which is not negative 10, it's 10. And some of you might be going, yeah, but isn't it plus or minus? There is no plus or minus in that original equation. Plus or minus is there when you take the square root and introduce a square root. So we end up with an answer to a question that is not valid. Okay? I'll give you another quick example. If I give you the following equation, and admittedly this is not a radical equation, it's what we call a rational equation, and you do the following, you say, well, x squared minus 4 is x plus 2, x minus 2. Oh, well, Mr. Way said, and he's correct, that you can cancel factors that are common on the top and the bottom. We end up with this statement. And I don't want it to be 20, my mistake. I want it to be, give me a second. I want it to be 4 is the number I want it to use, okay? So you end up with this statement. X plus 2 is equal to 4, which is elementary school stuff. X equals 2, right? 2 is not a solution to the equation. Because if you put 2 into the original equation, you don't get 4. You don't. You get 2 squared minus 4 over 2 minus 2. You get 0 over 0, and 0 over 0 is not 4. It's not even defined. So my point is we're entering into an era in your mathematical education where even though you do things by the books, you might get an answer that's wrong. And I'm telling you, in this particular lesson, you have to check for extraneous roots. So, I really grapple with this, and when I printed out my note package for this semester and I looked at it before I printed it out, I wanted to just get rid of these steps. Because really, your steps in solving an equation are to simplify and solve always. The first step here says isolate the radical term, and then the second step is square both sides. Let's just do that for the first example. Okay? For the first example, I want to isolate the radical, which means I need to subtract 5 from both sides and get that. The second step is to square both sides. Why? Get rid of the radical. So this is where the concept of simplification comes in. In the most general sense, if you have fractions, get rid of the denominators. If you have a complex fraction, simplify it. If you have radicals, get rid of the radicals. And if you do that, then what happens is you get 2x minus 1 equals 49. And once again, everybody, I've mentioned this to you many times. It's a philosophy I've adopted for the last 25 years or so. We go from a math 20-1 problem to something that I'll be generous and say a grade 7 student can solve, right? It's not an issue anymore. So you take something at the level you're at, you use some things that you've learned, and you turn it into something that is at a previous level. I add 1 to both sides, I get 2x equals 50, which means x equals 25. And it's really important that you understand when you check to see if it's a valid solution, my recommendation is this. You evaluate the left side and the right side separately. This will become important in Math 30 with trigonometric proofs. That we put in the answer we got for x on each side, and we see if they're equal. Well, 2 times 25 is 50. 50 minus 1 is 49. The square root of 49 is 7. Plus the 5 is 12. It checks out. Okay? But there's something else we are asked to do here. And what the other thing is we're asked to do has nothing to do with what the solution to the equation is or whether it's extraneous or not. It's just a skill that fits in good here. It says, what are the restrictions on the variable in the equation? So why would we have restrictions on the variable? Well, because you can't take the square root of a negative. This means when we talk about restrictions, we would say that the radicand must be greater than or equal to 0 because it cannot be negative. And you know, whoever's crafted all of the levels of math curriculum in 10C, 20-1, and 30-1 has done so in a certain way for a certain reason. This is in here because this is an important skill moving forward. It really doesn't have any bearing on what the solution to the equation is. It's kind of connected, but it's not really there. We solve this by adding 1 to both sides. So that means that in the equation, x has to be greater than or equal to 1/2. Let me, when I teach, we teach this again in 30-1, and let me really drill down deep. You can put your pencils down. You're not expected to know this, but some of you might be interested in the connection between the restrictions and non-permissible values and the solution and extraneous roots. Here it is. If this is your restriction, it means that these are the allowable values of x, correct? That's just a line graph of this inequality. If you solve one of these equations and you get a number that is not in this allowable domain, then it will be extraneous. So let's say you had this domain and when you solved it you got x equals 0. Well, 0 is outside of this domain, it's not a solution. But here's the weird thing. Just because you get a number in this domain doesn't mean it is a solution. Which is really strange, and I get that. And you would see examples of that in Math 30. We might encounter one here, but it's not a big deal. The bottom line is, this thing is a separate idea to everything else. You solve the equation and then you put it in to see if it works, and you do your restrictions by looking at the original equation. Let's try another one. Well, I have to isolate the radical first, so this is going to be the square root of 3y, the square root of 3y over 5 equals 6. I square both sides. When I square the radical, I'm left with the radicand. And now I can solve this. But wait, how do you solve this? Well, you simplify it. Non-fractions are simpler to work with than fractions. How do I get rid of this 5 in the denominator? I can multiply both sides of this equation by 5. These 5's cancel. I'm left with 3y equals, I want to say 180. So y is equal to 180 over 3, which is 60. I'm not going to write down our checking all the time. If you put 60 into the original equation, and you take 3 times 60 and divide that by 5, what do you get? 36. And the square root of 36 is 6. Negative 8 plus 6 is negative 2. That's what it's supposed to be equal to. It's valid. What are your restrictions? So we can put a check mark beside this. What are our restrictions? Which is, once again, outside of the realm. It's connected in a real bizarre way, but outside of the realm at this level to what we're talking about here. Restrictions. We would say that the radicand must be greater than or equal to 0. Well, that means y has to be greater than or equal to 0. You can multiply both sides of that inequality by 5 and divide both sides by 3. You're still going to be left with 0. Once again, just briefly, I just want to keep throwing this out so that when you hear me say it, if you have me as a 30-1 teacher, you'll remember it. This means that y must be a number greater than or equal to 0. If you solve an equation with that restriction and you get a number that is not greater than or equal to 0, it won't work. But just because it is doesn't mean it will work. So it's a strange thing. Let's do the restrictions here first. How many of you, we need to rearrange this for n. I'm going to give you two options. Listen to them first. The question is, would you move the n to the other side and solve it that way, or would you move the number to the other side and then do something else to solve it? How many of you would move the n to the other side? That's what I would do, okay? So if you do it that way, it becomes 5 is greater than or equal to n. If you do it the other way, you subtract 5 from both sides, right? So if I want to get n by itself here, do you agree I have to divide both sides by -1? Okay. We'll come back to that. Inequalities are taught back in grade 9, and then you don't touch them at all until now, basically. So I'll just ask the question. How many of you understand that if 5 is greater than or equal to n, n is less than or equal to 5? The basic kind of idea is you're reading this backwards. That's how I think of it. So if I have that, and I flip it over, that's what it looks like, right? And there's an equals to there I forgot to put. So this is the restriction right here. When I divide both sides of this by -1, I get n is greater than or equal to 5, which is wrong. Does anybody remember what you have to do? Right. When you multiply or divide an inequality, you have to flip the direction of the inequality. And my experience, and it may not be perfect, but my experience is that most students forget to do that. So I think it's better the other way. Anyway, that's the restriction. Let's solve this now. I'm going to move the radical over here and have n plus 7 here. So this radical is negative. I moved it to the other side where it becomes positive, and I turfed the -7 out of the way, so it goes to the other side and becomes positive. And now I have to square both sides. When I square n plus 7, I get n squared plus 7n plus 7n plus 49. Right? The squaring a binomial means to multiply that binomial by itself. And then this is equal to 5 minus n. Okay. It's quadratic. Well, this is the way things go. This is why we learn quadratic before we learn this, because sometimes these turn into quadratic. So what do? You zero the equation. You'll want to check my arithmetic there, my numerical math. I think it's okay. Are there two numbers that multiply to give 44 and add to give 15? 4 and 11? I think piling on a non-factorable quadratic at this point in this kind of question is a little much. Okay? I'm pretty confident that we don't have to write n plus 4 equals 0. Right? Okay. Those are our two solutions. Now, are these two solutions less than or equal to -5? Well, on a number line, I hope you can answer that question without invoking a number line, but here's 5 less than or equal to 5 is that. Is -4 in that domain? Yes. Is -11 in that domain? Yes. Okay. Are they both solutions? Well, I don't know. Just because they're in the domain doesn't mean they are solutions. We need to look at the original equation up here. And I'm going to start off with the, what did I say, -4 and -11. I'm going to start off with -4. Five minus -4 is 9. Root 9 is 3. -4 minus 3 is -7. It checks out, jackpot. So we can go ahead and commit ourselves to -4 being a solution. What about -11? Well, let's see, this is -11 minus root 16. Root 16 is 4. -11 minus 4 is -15. Like, that's kind of a mystery. Why is it that that happens? That this doesn't work even though we didn't do anything wrong? Well, first of all, it's not a valid solution, so you can strike it. It doesn't work. I don't want to get into too much detail, but it doesn't work because when you square a square root, you're treating it as if the square root were plus or minus. I hope you recognize that if this were plus and we isolate the radical and square both sides, you're still going to get the same thing, aren't you? Because this would become negative, but when you square it, it still becomes positive. So when you square it, you're actually solving two different equations, but only one of them is the true equation. You can think of it that way. All right, a couple more quick ones, and I think, does yours go from 3 to 5? Or do you have a 4? You have a 4. May I borrow that? Okay. I may need some help. M minus root 2m plus 3 equals 6. Is that correct? Okay, so that's number 4. That would mean m minus 6 is equal to root 2m plus 3. By the way, not that it really matters, but we are asked to do this. If anybody asks, that's what the restriction is. The radicand always has to be greater than or equal to 0. So I isolate the radical, and I square both sides, and I get m squared minus 12m plus 36 equals 2m plus 3. Just in case you're wondering, the m minus 6 squared is m minus 6 times m minus 6, and I'm foiling that out to get the m squared minus 12m plus 36. Zeroing this because it's quadratic. I believe that's what I get, which factors into m minus 3, m minus 11. And that means the solutions are m equals 3 and 11. Both 3 and 11 are in this domain, but as we've already seen, that doesn't mean anything. We have to put 3 in here. And if I do, I'm going to get 3 minus, I think it's going to be 3. Can you confirm when you put 3 in here and here, that the left side will be 0. So that doesn't work. If it were plus, it would work, but since we squared it, the mathematics rules don't know whether it was plus or minus because it becomes positive anyway. So 3 is gone. What about 11? Well, I put 11 in. 11 minus root 25 will be 11 minus 5, which is 6, and that works. And I hope that you're okay with me not showing all that work. I mean, you can do that on your own. What about 5? How on earth do I do this? Well, we're lucky because it's a radical equals a radical, so I can just square both sides. If I square both sides, I get 3h minus 4 equals 5 minus 6h, which means 9h. When I add 6h to both sides, I get 9h. When I add 4 to both sides, I get 9. H is equal to 1. I'm going to take a minute and throw 1 in there and see if it works. Does it? It doesn't work. Why doesn't it work, Georgia?
The first one is going to be a negative under the radical sign.
They're actually both going to be negative under there, aren't they? Let me show something to you now, and this will be our last example. We don't need to do number 6. I want to teach you something. In fact, we just talked about it this morning in our Math 30 class. Do you agree that has to be true? Forget about the equation. Just look at the fact that it's a square root of 3h minus 4. I hope everybody's capable of understanding it translates to that. On the other hand, do you agree? Is 5 over 6 about 0.83? Correct? What is this saying for h, for the value of h that you were allowed to put in? It's saying the following. It's saying that h has to be a number that's less than 5/6 or equal to 5/6, and it must be greater than or equal to 4/3. There are no numbers in that domain. There aren't any numbers in that domain. There are no numbers in the universe that you would be allowed to use in this equation. All right. Get some practice with these questions. I know it seems like a lot when I write it out this way. You certainly don't need to do every single question. And don't get lost in the whole restrictions domain thing. Okay, that's not what I'm going to test you on in this unit. In the next unit, yes. Okay? In the next chapter, yes.